Okay, and Inghao asked another question as well. Okay, let's look at this. Which statement is true? Okay, here is another question. So diagram shows a diver jumps from a platform. May I know which statement is true and why? So, okay. This is basically a diver trying to jump off the platform so that it could then, dive into the water. So there's a change in height. So from what you see here, this is a form of what? This is a form of energy change. So when you talk about energy, there's only one thing that really strike my mind as something that that's very closely related to energy, which is the principle of conservation of energy. Okay, we all know that energy cannot be created or destroyed. It can only transfer from one form to another. So it's very important to know this fact. So what happened is, assuming that there's no external loss in energy, so if the diver is standing at a very high position, jumping off the platform, that itself is a way for the diver to reduce gravitational potential energy. Because now it comes back to the point. Let me just write it down for all of you. Okay, so it comes back to the point where, okay, here. So we understand that this guy is at a very high ground. So if this guy is on a high ground, it will achieve what we call gravitational potential energy because it comes with height. Okay, gravitational potential energy. It comes with height. So the formula is quite straightforward. Okay, so we understand that this is m times g times h, mass times gravity times height. So that is for the diver. Okay, I'm just giving an example. So this diver jumped off the platform. Okay, so what happened? This action itself shows that the diver has achieved or has gained kinetic energy. So what happened is the diver loses height. So it loses gravitational potential energy, but it gains kinetic energy. So this fulfills the law of conservation of energy, correct? So this one is kinetic energy, because as the diver jumps off the platform, this is what happened. So kinetic energy, diver gains kinetic energy. So this is half times mass times velocity squared. So this is what's going on after the diver jumps off the platform. So it gains kinetic energy, okay, and it loses gravitational potential energy. But these two should equate because that's the principle of conservation. Yeah. So coming back to the question, it says kinetic energy is maximum at P. No, it is not maximum at P because at P it has the greatest height. So that wouldn't be a very good answer. Kinetic energy plus gravitational potential energy at R equals to gravitational potential energy at P. Yes, it seems like R hasn't touched the water, right? If it hasn't touched the water, this is actually the time when, this is actually the time where the diver is still not fully, has not fully achieved what we call the kinetic energy yet. So it is still halfway through. So the potential energy is there, and it has a combination of kinetic energy as well. So B would be a very good statement because it adds up to the total. Okay, it adds up to the total where it equates to gravitational potential energy at P. But again, as a good student, we never decide our answer firsthand, right? The moment we see B as the answer, we know B, is very close to the answer, or it's probably the answer itself, but we never really just dive in and just choose B and move on, right? So that is something that we try to avoid. So let's look at C. Kinetic energy and gravitational potential energy are minimum at Q. I don't believe so, because this is a combination, right? The law of conservation. So you will still have a mix of energy between gravitational potential energy and kinetic energy. And if you look at D, gravitational potential energy is maximum at S. I don't think so. That's like the least height. So yeah, From here, we eliminate, we have selected, and we have a conclusion. B is the answer. Okay, so B is the answer. So I believe that would be for the question. Let's